So lesson 5, we are still looking for solutions to quadratic equations. And when we ask you to solve something, we are asking you for x equals. So in the case of a quadratic, we could have two answers because we could have two x-intercepts, zeros, roots, all the same thing. So if we want to find the x-intercepts or solutions to this problem, we can use our graphing calculator. So to find the roots of this equation, I'm going to write it in as y equals 9x squared minus 12x plus 2. 9x squared, subtract, not negative in this case, plus 2. And to solve that problem, I want to see where it's equal to 0, which is on the x-axis. So I'm going to hit graph and see if my windows make sense for the problem. They're okay, they're not ideal. So what I see when I look at it is I don't need such a wide domain, and I need a lot less negative in the range. So let's adjust our windows so we can just see it a little bit better. So instead of minus 10 to 10, let's go minus 5. I shouldn't say minus all the time, it's negative 5. And my y min, I didn't need to see quite that low. So my y min, let's also go with negative 5 and see if that gives us just a little better picture. There. I want to know where that 9x squared minus 12x plus 2 equals 0. That's right along that line right there. So I'm going to get the graphing calculator to tell me the values of the zeros. Second trace. And I'm looking for zeros, number 2. I'm going to find the one on the left first. I am to the left of it. And I'm going to scroll along with my arrow keys till I'm to the right of it and hit enter. And it's marked the place that it's looking up there. Enter. Desmos will tell you the same thing. We're just using the technology to come to some interesting conclusions. So I have 1, 0 as x equals decimal 1, 9, blah, blah, blah. Ooh, that's ugly. The ones we looked at yesterday were a lot nicer than that. So x equals decimal 1, 9, 5 approximately. So you're not guaranteed that x-intercepts are beautiful, pretty whole numbers, or integers, or even just reasonable fractions. Second calc, let's find the other 0. I want to be to the left of it. Where am I now? There I am. I am to the left of it. I happen to also be below it. There we are. And it's put a marker for me. There, now I'm to the right of it. And I want to find the 0 between there and there. Enter. The other one is 1.138. Approximately. Another ugly but realistic x-intercept for this function. So we have an issue if we have a function like this one that's kind of ugly. And it's not nice to factor. And on the graphing calculator, our x-intercepts are kind of ugly. What if we were stranded on a desert island and we wanted to know the roots of something and the numbers weren't pretty and we didn't have a graphing calculator? Whatever would we do? Well, I have a formula for you. If we have a quadratic equation that's in this form and we are not able to factor very well, we can use the quadratic formula. This tells us the possible x-intercepts, or zeros, or solutions, or roots, all the same thing. So we're going to try on this question that we know the answer to, and see if we can come up with the x-intercepts using this formula. Now I'm asking you to trust me, but you really don't want me to prove it to you. For the first example, 9x squared minus 12, subtract 12x plus 2, the a value is 9. The b value will be negative 12, and the c value will be 2. So we've got it set up in the correct order because those are the important numbers that I need to put into the formula. So my x-intercept could be negative b. Well, my b value is negative 12. So negative b is positive 12. Let's make a little mark of that because I am taking the opposite sign to what b is. And right now, it's negative 12. All right, on we go. Plus or minus square root of, this is a long one, b squared. Well, the number b is negative 12 in this problem, so b squared would be 144. Subtract 4 times two different numbers. The first one is our a, and in this case it's a 9. And then I multiply it by c, which in this case is a 2. And the quadratic formula says divide the entire thing by 2 times a, which in this case is 9. Now we very carefully have to navigate these numbers, but the x-intercepts are there. All right, I have 12. Add or subtract whatever this thing is under the root sign. It's 144 subtract, see I'm doing order of operations, 4 times 9 times 2. I'm going to put the answer down for that because I would need to do this multiplication before I can subtract. 4 times 9 times 2 is the same as 36 times 2, which is 72. Or you can use your calculator. All over 18. Okay, 12. Add or subtract the square root of 144 subtract 72. Well, 72 happens to be half of 144, so this is what I got. Well, it's ugly, but it's getting better. I can't do this in my head any longer. So I've had to resort to a calculator. I have 12 plus or minus 8.485 approximately over 18 because the square root of 72 is kind of ugly. So here are our answers. The first one is, and I should be writing x all the way down here. The first one is x equals 12 plus 8.485 over 18. The other answer is 12 subtract 8.485. So I get my two possible roots from this. One of them's an add, one of them's a subtract, and we have to work this out with a calculator. So at the top I have 12 plus 8.485, which is 20.485, divided by 18, and I'm using a calculator, which is approximately 1.13. Interesting. My other x-intercept is 12 subtract 8.485 and then divide that by 18. Remember to do the whole top first and then divide by 18. And I get approximately 0.195. Interesting. Same answers we had before. I'm going to do two more with the quadratic formula, and then I've left two in your course notes for you and your friend to try. Okay, the first one. I want to find my x-intercepts for this quadratic equation. So I'm going to use the quadratic formula knowing that this is the number for A, this represents B, and this is C. So I'm going to write it out generically again just to make sure I remember it. Negative B plus or minus the square root of B squared minus 4AC over 2A. Okay. To find my x-intercepts, I need negative B. B is 4, so negative 4. Add or subtract the square root of B squared. Well, B is 4, so 4 squared is 16. Subtract 4 times A is 2. And C is negative 3. Sorry, that's root sign should go all the way across. All over 2 times A, and A is a 2. So once I put the numbers in, we need to start playing with this square root. So 16 subtract, and I always put these three numbers together first. So 4 times 2 times 3 is 24, but I have a subtract and a negative, so it's actually going to be add 24 all over 4. X equals negative 4. Add and subtract for two different answers. 40. Square root of 40 is not really pretty. So I'm going to use my calculator in a minute. But one of my answers will be negative 4 add root 40 and then divide by 4. The other x-intercept will be x equals -4 subtract root 40, all divided by 4. So with a calculator in hand, -4 plus root 40 is 2.324, about 5 when I round properly, over 4. Again, you have to have a calculator for this. Divided by 4 is 0.581 approximately. The other x-intercept is -4 subtract root 40. And I have -10.324, 325 I guess, all over 4. Divided by 4, I have approximately -2.581 as my second x-intercept. The last question from me is this one. Now there's a problem with this one. X squared minus 9 equals 8x. Be careful. We need to have this equation look like ax squared plus bx plus c equals 0, or we're going to end up with the wrong numbers in the wrong spot. So I'm going to reorder this thing first of all to x squared. I'm going to subtract 8x from both sides and put him second, because that's the order it's supposed to be. And I have subtract 9 equals 0. Now I've got it where I can see my a, my b, and my c, and I can find my x-intercepts. So x equals -b. So, whoops, I should have that showing for you. There we are. -b. So b is -8. So -b is like the negative of -8. Becomes +8. Add or subtract square root of. B squared is the first thing, and that's -8 squared. Remember, it's -8 times -8, so you always have a positive here, 64. Subtract 4 times my a value, which is an invisible 1, times my c value, which is -9. All over 2 times a, which again is a invisible 1. So x equals 8, add or subtract 64. Then I have subtract 4 times 1 times -9. Okay, so I'm subtracting a negative. I'm going to get a positive. 4 times 9 is 36, all over the number 2. 8, add or subtract. 64 plus 36 is 100. That's a nice number. So this even works when your intercepts are lovely, and you could have factored, but you can still use the quadratic formula. It always works. So 8 add or subtract 10 over 2. So my 2x-intercepts will be, the first one would be 8 add 10, then divide by 2, which is 18 divided by 2, which is 9. So my 1x-intercept would be 9. The other one would be x equals 8 subtract 10, and then divide by 2, which would be -2 over 2, which is -1. Those are my 2 x-intercepts using the quadratic formula.